All right, let's get rolling. Hi, everybody. My name is Aneesh. I am the CTO at Quilt Data, and we've been spending the last 7 years really thinking about this concept of immutability as it relates to trust. And during the last 12 months, we've been lucky to learn from about 10 new customers in the enterprise that are using both Nextflow for compute and Quilt for storage. And for all of the dozens of Amazon services, if you actually squint at the cloud, there are really only 3 things going on from a virtualization standpoint. So you've got network, you've got compute, and you've got storage. And a lot of us are in this room because Nextflow has made the process, has democratized this process of building compute pipelines. And what that does is it immediately puts pressure on storage. So you've heard the saying, all roads lead to Rome. Well, in the Amazon cloud, we feel like pretty much all data drains out into blob storage, in the cloud as a whole. And the issue with S3 is it was really designed as a high-speed key value store to function as a backend for websites. So you can store your data in S3, but it becomes difficult to actually manage it there. And there are a few problems that occur across the enterprise, especially where you have teams with mixed functions. So you're going to have teams of developers and non-developers. I think of this as the wet science and dry science interface. So wet scientists are very particular about which software they will and will not use. And one of the things we've noticed is that if you ask them to use S3, it becomes quite a stretch for them. And so one of the problems, and this was brought up in the keynote earlier today, is that where is that file? Actual findability and spinning up your own Elasticsearch cluster to index S3 is not a trivial task. Files can be moved, they can be deleted, they can be copied, they can be orphaned. And a lot of the fear we have as a community around data management is that we grew up in a world where things were mutable. They could be changed out from under our feet. And the whole concept of immutability is that you now have this immutable, never can change frame of reference, which allows you to build trust as a flywheel inside your organization. So the way to think about S3, I'm a great fan. S3 to me is the 8th wonder of the world. But if you're only able to write data, what good is a write-only database? You not only want to be able to put things into S3, but you also want to be able to pull them out so you can reuse them across time, across machines, and across collaborators. The other issue that you'll find is that the reason silos develop in the enterprise, you've got Smartsheet, you've got Ignite, you've got Box, you've got Dropbox, you've got S3. The reason these silos develop is that different user groups have different preferences for where they want to store their data, and that's the cause of these silos. And the other thing, as was talked about this morning in the context of execution context or the context of a data pipeline, is that you want to know, when you look at a given series of pipeline outputs, the provenance of that data. Where did it come from, first of all? And second of all, when a pipeline emits a series of outputs, it rarely emits a singleton. It's not a single file. It's generally a collection of related files. And so the other thing we found missing from S3 was this concept of the concepts of provenance and collections. And what we've done in the open source, we've been building this for over 6 years now, is build a fully open source package manager for S3. And you can find us on GitHub. We would love to have your contributions. And the core there is really what I'm going to be talking about today. And it's a piece of software called Quilt 3. So you can acquire this the same way you acquire any standard PyPI package. And the first concept I want to introduce to you is the concept of a logical or immutable data package. So in order to create a package, you can use, if you're familiar, how many people are familiar with like Red Hat Package Manager or NPM or PyPI? We've all used package managers before. The simple leap that needed to be made is package managers have typically been used for software binaries or for software source files. And we've taken that same set of paradigms and brought that to a package manager for data. So when you want to create a package, it has a handle, which you see there on the far right, foo/bar. And you can push data that's been materialized on your machine, and that will actually nest that data in S3 for you in the form of an immutable package. The second thing is that you can now also acquire dependencies. And you can acquire not only dependencies, but this is the key thing that any package manager needs to do. You need to be able to pin those dependencies. Why? Because I don't want to talk with my colleagues about the data or the foobar package. I want to talk about it at a specific snapshot in time. And we all want the confidence that we are looking at the exact same frame of reference for the data. So we're going to talk now a little bit about how you can use immutable data packages to feed your Nextflow pipelines. And the key thing here is a pretty simple concept in computer science known as a directed acyclic graph. And what I'd like everybody in the room to start doing is to think about the processes within their organization that both process and produce data as a graph of nodes and edges. So you can see an example of a DAG on the far right there. And this is essentially the idea that it's packages and pipelines all the way down inside your enterprise processes. And so what that means is the nodes are essentially the nodes in the diagram. A little bit confusing. We're not talking about compute nodes here. The nodes in the diagram are the data inputs to your pipelines, and the edges are the pipelines themselves. And so you can see there we've got kind of a join point at the right. So we have an implicit sync barrier where I've got two parents. And so there are two different data sets that are feeding into two different pipelines, but that data is then joined to produce a common output. And we reflect that in this directed acyclic graph. So the reason this becomes important, and if you remember no other slides from this talk, this is the single most important slide, is that every run of a pipeline in your organization you can think of as a pure function in three variables. So the three hashes, we'll talk about the one link to rule them all in just a second, are a code hash from Git, an environment hash from Docker and Nextflow, and a data hash from Quilt. And that's really been our job, is that this kind of provides you with a GPS for all of the executions or pipelines that have happened within the context of your organization. So with three hashes, you can fully reproduce any run. And there's a special property that pure functions have, and it's called idempotency. And the idea behind idempotency is that any function, if it's pure in designation, that has the same three inputs or the same n inputs will always produce the same output, right? We've all heard about findable, accessible, interoperable, reusable data, but the thing that really drives reuse is the ability to reproduce any historical artifact, pipeline output that your organization has produced at any time. And we find that the ability to do this reproduction across time, across people, across machines is really what drives the compliance process, because compliance at the end of the day is proving that you did what you did when you said you did it. And that, again, becomes very simple if every realization and every pipeline run, every knowledge generation process inside your organization is driven by these three hashes. So very quickly, this is now the technical part. So we just talked about how immutability allows teams to agree across time, across space, across machines. But these teams, again, are cross-functional. And they're cross-functional in the sense that the data that lands in S3 isn't only consumed by programs. It's also consumed by people. And so also in the open source, we've built something here that is called the Quilt 3 catalog. And the key point of the Quilt 3 catalog is that I can traverse, or in an interface that looks like Box or Dropbox, I can inspect an immutable collection. And what is that? That is, first of all, the lineage, so all the mutations to the data set. Second of all, it's a cryptographic hash. So you'll see the data set has, in the URL, we have a SHA-256 hash. What is that? That's something that's called a top hash. And that top hash is the hash of all the hashes of the data set. What does that mean? That means that every time you produce a data set, you have a digital fingerprint that is tied to the contents of that data package. And so you can see not only the lineage of the package here, but you can see the actual contents, and you can start to look at, okay, hey, I've got a data grid in here. And we leverage the open source, so there's a very strong series of libraries called Vega, Vega Lite, and Altair. Jake Vanderplau worked on that. It came out of some of the work at Stanford. And this is a 96 well plate, and you should, with one or two lines of code, be able not only to store the pipeline output in S3, but to visualize it so that scientists can start to consume these inputs and use it in an actionable way. And I'll show you one more quick example here. So, funny story, I was walking through the lobby yesterday, and I heard the words, "It was such a pain to get IGV running on top of data in S3." And so our vision, he's out there, our vision here, Tony, how are you, is really that data scientists should never, ever have to make a PowerPoint presentation. If they've done the work of putting an application or putting the data in S3 in its native format, it should be trivial or just a few lines of code to actually extract that. So what we've done here is we've used the IGV. This is one of dozens of applications that are embedded inside Quilt. And all the user is responsible for is telling IGV which files in S3, your BAMs, your BIs, your CRYs, to actually integrate into that genome track. And it's not, as I said, about IGV. It's about any type of data that you land in S3. That should be visual, not only to machines, but also to human beings. Because the process of people agreeing on what is true requires them to actually see and consume that data, and not everybody is a developer. So very briefly, questions every data set must answer. Kind of a really interesting repeat of this morning's talk. He's seen his slides, he hadn't seen mine. But the data set should answer this question of where did the data come from, why should I trust this data, and how do I use this data? And this concept, one of the things that we've done is because S3 is totally schemaless, that means that an immutable quilt package contains not only data, but metadata, charts, documentation, and lineage. And that pentad, those are the 5 things that you want to make sure that you account for as you build your data sets. And I've talked to you a little bit about the 3 hashes for compute, and I want to bring up Quilt's product manager, Ernie Prabhakar, and he's going to talk to you about an exciting Nextflow integration with those hashes. Thanks.
Right. I hope all of you are able to make it to the coffee shop. Aneesh and I were still finishing our slides, but if you haven't yet, be sure to pick up your Quilt t-shirt. And the idea of one link to rule them all. So Aneesh has a lot of powerful images of how data should be. Your data should be this canonical, it should be findable, it should be usable. And I keep telling Aneesh, like, we don't want to make people feel more guilty about not making their beautiful data and making it all canonical. So what we're here to do today is to take away your data shame, but making it as easy as possible for you to get the data you've always wanted. And this is what this new magic thing we're calling the Quilt plus S3 file system, which is basically a way that you can take all of your existing Nextflow pipelines and trivially add them directly into S3 via Quilt, where Quilt will manage all of the versioning, the verifiability, and the visualization for you with basically 0 extra effort on your part. And this Quilt URI is a special URI scheme which has an S3 bucket. Currently it only operates on AWS S3. And then you specify the package, you specify a version information, and a path. And the way it works is that you can go in to Nextflow today, and so I saw the poster for Sarek yesterday. I said, oh, I should see if I can get this to work. And in fact, you run it just like you do today, and where you have the outer parameter, instead of putting an S3 URL or a local file system, you just put in this magic one link for the Quilt S3 file system, and you get, let's see, I guess I need to drop out here. You get this, if I can find the, where's our catalog? Right. So this code, when I ran it at 3 a.m. this morning, generated this package here, which with a little help, and this is actually, and so this is a package that was basically taking the stock Sarek code there, no configuration files, no code changes, literally just running it with one additional parameter. It takes all of the code, all the amazing hard work our friends in Sweden does, and puts it into a beautiful visual package where everyone can see it. There's a little glitch here in that we don't have a live HTML, but normally this will be a live HTML QC file that your end users, your business people, your mom can come in and see exactly what this data is, how it works, interact with it, play with it in real time. And all the files are here. Everything is just pulled up there. It's an S3, it's organized, it's beautiful, it's visual. But the best part of all, well, 2 things that are great. One is that this is, it's not just idempotent, it's omnipotent. It's always there. Every time you run the code, have any of you ever overwritten an important data file in S3 or on a local file system? And so the idea is that you never lose a data set. Everything that's written up there just overwrites a new version, and you can just drop down and grab the last version, the last night's version, the last week's version, the last year's version. Everything is all there. As long as you turn on versioning in your S3 buckets, we will make sure everything magically always stays the same. You can keep rerunning the analysis as often as you want, and nothing ever gets lost, and it's smart. If you rerun the analysis and no files have changed, it won't upload anything. So your timing, your storage costs, everything is much simpler. We use the magic of Quilt packaging to take care of all that on both the client side and on the back end. But the favorite piece, and this is partly manual, but so we automatically bring in all the metadata from Nextflow. So the configuration, the parameters, everything is stored in Quilt. This information is also available through Athena SQL for querying. So if you have all this data there, once you get the formats normalized, you can then query across it using a query tab inside the let's see if I can bring this up here, and at least you can, I don't know if it's been enabled on this system yet. It's not enabled on this system, so. And then, but one thing, and this part is still manual, we haven't got this automated yet, but we get lineage. So the idea is that every time when you run a data, we'll be scraping this information, and we're talking with Nextflow about how do we make this more canonical and standard so everyone knows how it's there. But the idea is that every time you run your data, the system will automatically keep track of the magic quilt URL that you pulled it from, the processors that we used from Nextflow to generate this thing, and all the Docker images of the environment. So this is the first time I think I've ever seen this, and maybe for you, the magic idempotent hashes that allow you to say, I know exactly where this data came from. I know every piece of data that was pulled in there with an immutable, cryptographically secure hash. I know the entire environment it was running on in terms of the Docker containers with their images and their hashes. And I'm still pulling the right data from Nextflow, but the idea is that you know exactly which pipelines, which versions, which sequences, which codes were used, so that there's this ironclad, rock-solid guarantee that you have exactly the data you expected, and that everyone up and down the chain can trust it and know, as he said, it's only really data when everyone agrees on what it is. So let me just jump back in. And so how do you have to do this? So you need, this may work on earlier versions, you need a recent version of Nextflow, you need to install the open source package, you need to have your AWS configuration set up so you have your credentials somewhere, and then you need an S3 bucket that you can write to. That's it. You just need to do that, and then you create Quilt URI, drop it on your pipeline. If it doesn't work, let me know. Version 0.1.0 was posted at 4 o'clock this morning, so there may be a few bugs, but we're here for the rest of the conference. We would love to get you set up and pushing your packages from your pipelines into your S3 buckets before you leave this conference. And so this is what we are here for. We're all former scientists who decided to go into technology because we want to make science better for everyone. And this is one of our customers who was one of the really early adopters of using Nextflow with Quilt. And this was a game changer for them. This is how they went from being a bunch of scientists trying to discover stuff to being a lean, mean data producing machine that generates value for their customers, for their stakeholders, and for the world by generating science that saves lives. So, and the key missing piece in a lot of organizations is really trust. Do I trust my data? Do I trust your data? Do we trust their data? And by bringing everyone together around Quilt packages, we really do hope that this one link to rule them all will make a more cohesive organization and a more efficient data community. So you can grab the QR code, you can have links to all the packages, the source code, everything there. And of course, we're here for the rest of the conference. I'm the last thing between you and lunch, so I will stop now. Thank you very much.
So thanks for the great talk. We have a question from Yaubo. So can Quilt 3 handle data stored in Amazon S3 Glacier?
Yeah, that's a good question. So, yeah, the question is, does Quilt work with glaciarized data? It does, but by design, you cannot get object on glaciarized data. So you'll know the data is there, but you won't be able to do the fancy things like displaying the data. And of course, if you actually do need to retrieve the data from Glacier, you'll pay for it.
Okay, so another question. So how does this work with datasets which have strict regulatory restrictions such as clinical data, HIPAA, HITAG, and so on?
Yeah, I love that question. So first of all, the thing we didn't state is the future is your cloud, your rules. The days of you sending your data to someone else's cloud are numbered. The way this works with compliant and sensitive data, it's your S3 buckets and no third party can see it. You can add KMS encryption on top of this data. So don't send your data to anyone else's cloud. Keep it in your own private cloud, and that will give you the strongest compliance guarantee that you can get.
Thank you.
Thank you.